pH, that kind of thing. Give you more examples later on. Now, another possibility. Now, what about instead of using two chemicals, you have this chemical alone. Okay, so this chemical alone, as indicated above, so when you have this chemical, it can go to the left or it can go to the right, right? At equilibrium. So in the case is to the left, then it will need to associate with a proton in order to form that. So for association, then we will need to concern with a reverse case. So there's a reverse, right? So the reverse case. Then for dissociation, then you need to go the forward case. So now consider both, and there will be a derivation. Okay? So here comes the derivation. And your logic, very important to exercise your logic. Okay, step by step. Okay, follow the logic. So now you have the HA minus alone, right? So you're going to have that in neutral water. Water has no excess H plus, no excess OH minus. So now once you throw that in, you're going to have proton and A2 minus available. Up to this point, then you have the H plus available. Otherwise, you don't have any H plus available. This is the key thing. Okay, so in red, then I said, now you have the H plus available. Very important understanding. So you are calculating the pH, right? So you're going to calculate for whatever is free left in solution. Yes?
So that's ignoring this auto-dissociation of water then, right? Because there will be a little H plus in solution.
The K value is going to be larger than the KW 10 to the minus 14. Otherwise, water is always neutral then, because the K value is larger and therefore allows the ionization. Okay, so keep that in mind now. So you have the total H plus available. Now once H plus is available, then it can associate with the remaining HA minus to go to the left. Some of the HA minus to go to the left. Notice this is a weak stuff, a weak acid. It's not going to be totally ionized, right? Only some of it ionized. But those ionized will give you the proton. Okay? So that is the key thing. So go through what you try to follow me, one at a time, so you can copy one at a time, rather than just copy the whole thing and miss some of the logic up there. Okay, so we go slowly, so you will follow one step at a time. So you have any question on the first line? Now, the second line, right? As I said, so the H prime will represent all the proton come from HA minus. Now for association, some of the HA minus, right, will associate some of the H plus from the total, not the total, only some of it. But then whatever those associate will generate the H2A. So this is net product, what it amounts to. So by knowing this quantity, then we know the association product, right? This is the association product. Okay, so this is the key point here. Now, the remaining H+, remaining one will come from the different, right? Total. Now, the 2 minus and the H+ will come from the same chemical, line 1. So the H prime is equal to H prime from the same molecule, right? So the HA minus dissociate into H+, then representing this total is same amount as A2 minus, right? They come from the same chemical, okay? Because there are so many H+ here and there, then if you write the counter ion, this would be a counter ion, then the picture is clearer, right? So this is a counter ion for H+ total being ionized. So this is what you have in solution. So it's equal to now those free and those associated. So this represents, after ionization still remain free, while those associated with the HA minus now become H2A. So this is the product, the counter ion to represent those associated. Okay? So the associated amount plus the free is equal to the total. So this is how it is written. Any question with how this is written? Okay, so now derivation, right? So then the A2 minus is equal to this equilibrium writing, right? This Ka2 is equal to the product over reactant, right? So Ka2, this is Ka2. Ka2 is equal to these two products over the reactant. So rewrite, express for A2 minus, then you get that, okay? So Ka2 products over reactant. So the equivalent will be like this. Okay, so follow up from here is equal to, instead of writing the A2 minus, you write the equivalent, right? The equivalent is up here. So instead of that, then it's substituted by that. Okay, continuation. Then this plus, instead of write H2A, then you write the expression for H2A, right? So based on Ka1, okay, equal to that product over reactant. So reactant is equal to the equivalent of that. Then just recopy whatever is up here, then down here. Okay, so any question with this? Okay, then you rewrite, okay, then this is Ka1, so every value is going to be multiplied by Ka1. So Ka1, Ka2 multiplied by Ka1. Okay, similarly here, Ka1, so on and so forth. Algebra, then you're going to end up with that. Okay, so copy this down and do the detail as you review the concept. Do the detail at home and end up with this algebra. Okay, so copy that. Now, this plus sign, whenever you see a plus or minus, is comparison, right? When you compare, something can be reduced in terms of magnitude. Now, the Ka value is often like 10 to the minus 4, 10 to the minus 5 kind of deal. And concentration is often 0.1 or 0.01 kind of deal. So this is going to be larger than that, okay? So once this is larger than that, then the Ka1 will disappear in the picture, okay? Then your H2 will multiply HA minus, right? H2 multiply HA minus, and then the HA minus move to the right. So multiply becomes divide. Okay, so whatever up here, then divided by HA minus. Kind of cool. So after all that labor, then they cancel each other. Then it reduces to just that. So what is the pH? If you remember it, then it's pK1 plus pK2 divided by 2. After doing all that. For the case of when you dissolve HA minus, So, right, this is what you dissolve in water. What is the pH? Will be simply pH equal to pK1 plus pK2 divided by 2. Isn't it real simple in terms of formula to memorize for, right? So once you write this picture out, then you know this is Ka1, this is Ka2. Okay, pH, okay, the two p values plus, and then let's be fair, divided by 2. Then that is your formula, okay? So I will accept that you use this formula to calculate for this condition. Now, if you are not here or you don't remember this formula we derived today, then you might go through a real long calculation and spend half an hour to get to the same final answer, okay? So memorize the formula. If I give you a sodium, HA, salt, okay? This salt dissolved in water. What is the pH? Then you just employ that formula. Any question? You sure you know this? I would be really disappointed if I put this on exam, then you